My name is Mark Schaefer with GraniteKey, and we at GraniteKey, we do security management, planning and design services, and we do security implementations, which generally include software development, systems integration, and business process engineering. And finally, we provide management consulting services. It's very important that when designing for security, you have to view it very similar to quality, where both management and engineering need to understand the quality or security mindset and how that affects the security of the system. Security, again like quality, has to be done at a holistic level, the whole system level, as opposed to the component level. So our agenda is to really understand how security is an extension to quality. And like quality, security itself is not a business objective. The business objective is to save money. It's really about your return on investment. And so let's really try to understand that as we go through the presentation here. But first, let's talk about the security environment. If you look at our slides here, the system. And I think this is very self-explanatory, but let me go through this and really illustrate the metaphor, the analogy that we need to think through when we're talking about security. One is you want to protect an asset. And in this case, it's money. It could be intellectual property. It could be a product that you have. And what you do typically is commonly in security, you use some kind of technology to protect that asset. This would be an integrated circuit, security algorithms, and imagine it's the lock on your front door. And as you can see in this particular example, that is not enough. You really need to consider several other factors. And a lot of this is very much common sense, but it's very easy to really focus on the security technology when in reality the security technology is just a very, very small component of the solution. One is to think about is the process. Where are the keys, for example? And the classic analogy is I got the key under the doormat and I've got a great lock on my door. Very, very important to understand that from a technology point of view. And finally, the system. In this case, the plastic bag. I can have the best security technology in the world, but if my system isn't secure, it really is pointless. The weak link in the chain is the system. So now let's take that analogy and let's extend that to a real system. Same analogy, let's look at a real system. In this case, let's say we have a host and a peripheral. Let's say the host is a PC and, for example, the peripheral might be a battery. We want to make sure that we don't have any clone batteries in the system. So what we can do from a technology point of view is we can take, for example, a board ID chip, and we can have keys stored in each chip, one on the host and one on the peripheral, and we could do an authentication. And the idea here is that the board ID chip or the security chip on the host is going to authenticate the chip on the peripheral and will refuse to operate if the peripheral does not have a proper chip in it. And let's say, in the case of a board ID chip, the chip cannot be easily cloned. So what now do we need to do to secure the system? What is the process? What is the system? And here's where the complexity comes. A security chip by itself can't do anything. But what it can do is it can send a signal to an application that would, for example, enforce the security algorithm or the security measure that we've chosen. The problem is that it's very easy to reflash the software. So instead of trying to hack into the security chip, you can reflash the software. That's what's called a scalable security threat, meaning that anybody can download a piece of software without any special equipment and reflash the application, especially in a PC environment. So what are some of the things we can do to increase the security? We're going to go through a path here where we're going to increase the security gradually. One is the security chip can have a hardware line that connects to the power source, say the power supply, and it can disable the power if the peripheral is not authentic. And the reason why this improves security is because even if you reflash the application, in order to hack into the system, you also have to grab a piece of hardware, a blowtorch, a pair of pliers, a soldering gun, a magnifying glass. And not a lot of people are going to be willing to do that. So what you're doing is you're actually reducing the scalability of your threats. So this actually improves security. It doesn't eliminate the number of hackers, but it significantly reduces them. Let's say that's not enough. Let's say this is a military system. If this is a commercial application, you might stop right there and say, I don't need to go any further. But if this was a military application, you would want to go a little bit further. Some of the things you might want to do is you might want to put what's called a secure boot in there. And the idea here is that if the firmware was changed, that the system would not boot up if the firmware that was on the system had been modified. Some other things you can do. You can have various legal, auditing, and inspection business processes. And a lot of times in a strong legal environment, for example, what you can do is you can rely on these business processes auditing. You can audit your suppliers. So a lot of things you can do to improve your security. So what we're not really talking about a technology, we're talking about a process. This is like quality. It's got to pervade the whole organization. The security technology is a very small part of it. Some other things we can do. We can put a metal box around the system. We could even put an explosive in the metal box if we wanted to. We could put a security guard in there if we wanted to. This is a financial decision. The question is, how much value is stored in your system? If somebody hacks into it, what is the cost of failure? And how much does it cost to put each of these measures in there? And what is your return on investment? It's not a technology decision, it's a financial decision. One of the most important concepts in security is really understanding the security level. And unfortunately, this particular diagram is something that management often does not understand and grasp, yet this is one of the most important decisions management is going to make. And that is, the idea here is that if you want more security, you're going to have to spend more money. And the problem is, how do you define security? Most managers don't understand the difference between low-level security and a high-level security. So let's go over some general guidelines. It's very easy to get caught up in the technology and things that are relevant. But let's really focus on what's really important. As we indicated before, it doesn't matter how powerful the lock is. Where do you store the keys? That's one of the most important things in security. So even if you have the best security algorithms that you're using, if you don't have a security chip, then your system is going to be vulnerable. And it doesn't matter what technology you're using. One level above that is you can have what's called logical protection. There's a class of chips called Secure E-squared where you can store the key inside the chip. And the chip has logical protection. So what that means is that if you don't have physical access to the chip, if you only have access through the bus, that no matter how much you bang away on the bus and send signals to it and try to confuse it, you can't get the data out of the chip. However, if you had physical access to the chip and you broke the chip open for $5,000, $10,000, $15,000, you can get the information out of the chip. So let's go to the next level, which is physical protection. There's a class of chips, and one is the board ID chip, and that falls into the same category as the smart cards, which is that even if you had physical access to the chip, even if you had a scanning electron microscope and a bunch of PhDs, and you hammered away at this chip, you still can't get the data out of it. And let me give you some examples of where that's used. In set-top boxes, in satellite TV, at one point, something like 50 or 70% of revenue was being pilfered by clones of set-top boxes grabbing cable and satellite subscriptions. And they started using smart cards, and that number went down significantly. Certainly in the single digits, if not close to zero. The next level is system level protection. And now we're talking about the plastic bag. The idea is that even if you have the keys stored, and even if you have the best security technologies, you really have to understand, again, at a holistic level, what is particular to your particular design and system that needs to be secured. And so when a management comes in and thinks about their security level, how do they distinguish between logical protection and physical protection? Most of the folks don't really understand the difference between one technology and another. They're really choosing the cheapest technology. And one measure is what's called FIPS level certification. And this is something that is used in certain cases where managers, people who are making decisions, want to make sure that a chip has a certain minimum level of physical protection. So for example, a Secure E-squared does not have FIPS level certification, whereas a board IT chip does, as well as a smart card. And so unfortunately, we run into situations where we don't want to end up where our little friend is in the bottom right-hand corner, where we want a high level of security and we don't want to pay for it. And so the way we can achieve that is to sort of confuse the issue about what is the difference between one security chip and another? They're just secure. And the idea here is that they're very, very different. And the idea here is to understand what do we need to do to have enough information available to make the right decision.